Imagine this. You're sitting on a merry-go-round. It starts spinning, slowly at first, then faster, and suddenly you feel like something is pulling you outward, trying to throw you off. But here's the twist. That pulling outward feeling is not what keeps you moving in a circle. In fact, the real force is doing the exact opposite. This is the learning studio, where physics becomes simple, sharp, and unforgettable. Let's break circular motion like you're five. When something moves in a circle, car on a curve, earth around the sun, a kid on a swing, it is never moving straight, even if its speed is constant. But physics wants everything to keep moving straight. So to force something to go in a circle, something must pull it toward the center, always inward, every second. That inward pull has a name, centripetal force. It simply means center-seeking force. Without this inward pull, the object flies off in a straight line. Exactly what you feel when the merry-go-round spins too fast. Example 1, car taking a turn. You turn the steering wheel left, the tires push the car toward the left. That inward push is the centripetal force. If the road is slippery and that inward force disappears, the car slides straight, not in a circle. Circular motion fails without centripetal force. Example 2, planet orbiting the sun. The planet wants to fly straight. The sun's gravity pulls it inward. Straight motion plus inward pull equals orbit. Take away gravity, planet shoots into space. Example 3, swinging a stone on a string. Stone spins around your hand. The string keeps pulling it inward. Cut the string, stone shoots off straight, not curved, not spiral, straight, because without centripetal force, nature always chooses the straight path. Example 4, roller coaster loop. At the top of the loop, gravity is pulling you inward. At the bottom, the rails push you inward. Different forces, same job. Keep you in the circle. If the inward force becomes too small, you fall. If it's just right, you complete the loop. Why students mess this topic up? Most people wrongly think there's an outward force. That's just your body wanting to go straight, while the car or ride bends your path inward. You're not being pushed outward. You're resisting the inward pull. Now here's your curiosity hook. If centripetal force is always inward, what happens when the inward force becomes too large? Why do cars flip? Why do ropes snap? Why do planets crash? We'll break that in the next chapter. This is the Learning Studio. Subscribe to keep the full physics journey smooth, clear, and genuinely useful.